Okay, let's look at number 26. So it says I have 1,200 feet of fencing. So hopefully you're kind of thinking of linear, which usually deals with perimeter. Now in number 26, the only difference is it's not just around the four sides of the rectangle. There's actually some dividers that go in the middle. So that would be part of the 1,200 feet of fencing. So this is the diagram that was given, and notice that it wants us to express the area. Well, area is just length times width. So when you get started, you know, you're probably going to have a of x equals x times y. And there's nothing wrong with that, only it says I need to write it as a function of x. So I need to get y in terms of x. So that's when I really need to look at that first piece of information about 1,200 feet of fencing. So just like you would do the perimeter, you know, you would have x plus y to do the four sides of the rectangle, but then you also have the two parallel fences, we'll call those, in the center. So you're really adding up 6 sides. So we can simplify that by saying 2x plus 4y equals that 1,200 feet of fencing. And then I just need to isolate y and get y by itself. So I can subtract 2x. So I have 4y equals 1,200 minus 2x. And then I can divide by 4. And so y equals 300 minus 1/2 x. So now, instead of this y, I can write it differently. I can write it 300 minus 1/2 x. So now when I'm writing my final function, I can say x times the quantity 300 minus 1/2 x. Now that's really all you had to do for number 26, but you could kind of go further. You know, let's look at what kind of function this is. It's going to be a quadratic. Do you know if it's opening up or down? Hopefully you are looking at that quadratic term, knowing that it's going to open down, which means it's going to give us a relative max right where the vertex is. And so you could find the maximum area because it's going to go right through that vertex.